So beyond the single table strategy, there's also another strategy called the joined normalized strategy or normalized strategy. So for instance, in this case, if you have the base class question, and you might have different types of questions, you know, true, false, fill in the blanks, multiple choice, right? You would implement it using something like this, where you have a base class called base question. Here I've appended the keyword joined at the end of the class, just to keep in mind, you know, keep track of what strategy we're using, because you could implement it in three different ways, right? You could have the same class and three subclasses of this base class, but to distinguish the three different versions, I've appended joined there. So if you don't want to use the default implementation strategy that comes out of the box with JPA, you can override that and say, no, I instead want to use the joined strategy, right? And the way you do it is you use the annotation inheritance and say strategy equal inheritance type dot joined. Right? This tells JPA that says, you don't want to use the default implementation where I put everything in one single table. Right? You want me to break it up. Right? You want me to break it up. In this implementation, here we have the two other classes, true or false, and fill in the blanks, right? So they both have different fields. So this the true or false has an additional Boolean is true, and the fill in the blanks has a variable. And the implementation is as follows. So it's going to break it up into three tables, right? We're going to have the base table representing the base class, where we have the join base question here that has the four attributes, right, that are specific to the base question and the primary key ID. But the other two, right, are going to have, you know, individual fields, right, that keep track of the fields for the true or false or the fill in the blanks. Right? For fill in the blanks, we have the variable varchar, and for the true false, we have an is true. Notice that something missing here that I would have loved to see here is that this primary key is also a foreign key. Okay, JPA does that for us. JPA is making sure that these IDs are the same. Right? That this ID, when I insert the join fill in the blanks, that ID is the same ID that I use for the record in the base class, right, in the base type. But the database is not enforcing it, right? The JPA is enforcing it, right? So it's unfortunate. I would have loved to see here the database also enforcing the fact that this is a one-to-one, right? That this record is split, right? That the values are split between two tables. You know, half of the fields are in one table and half of the other fields are in the other table, right? And that these IDs need to match to know that actually they belong to the same object instance, right? Even if they don't belong to the same records, we have separate records, right? So yeah, so this is what most people would understand as most intuitive. You have three classes. Well, there should be three tables, right? And when you want to retrieve an instance of this record, you have to join this record with the base record, right, to recreate the entire original object. That is why folks avoid this strategy, right? Because it's a join. The performance of using this strategy is slower. You know, it's a quadratic performance versus the other one is linear, right? So yeah, folks would stay away from this implementation. Yeah, these are just the repositories. The other strategy. Here's just an example of creating three base questions, right, with the values 1, 2, 3. And here we have two questions, right? A one false, true, false, and another one fill in the blanks. Notice that the IDs 3 and 2 match the 1 and the 3 and 2 from the base question up there. Okay. The other implementation is the one we just saw, the denormalized, where if you have the same classes, the classes don't change. And from Java's point of view, these are just base class and two inheritance. Two are inheriting from a base class, so that doesn't change. The only thing that changes here is that we are choosing a different strategy. Here, the strategy, we say that it's a single table strategy. This is the default strategy. So if you leave out the inheritance tag here, this is the strategy that it would use by default. If you don't say anything, this is the strategy that it would use, so that if you have the same exact classes, the only thing here we're changing is the inheritance tag, right? That's the only thing that changes. It's the same POJOs, right? Same plain old objects, Java objects. So the difference here is that we added D type, right? And all the fields, it's kind of like the inheritance works the other way around, right? In object orientation, we think of these derived classes inheriting their fields from the parent class. But when it's implemented, it's actually the reverse. It is the base table that's kind of like inheriting all the fields of all the derived classes, right? So all the fields from the leaves go up to the root, right? As opposed to all the fields in the root, being inherited by all the children. So it's kind of backwards. Just like many things that are backwards when you map these two worlds. The last one, the other strategy, is called the table per class strategy. Right. This one is kind of like this kind of like an in between these two strategies, right? One of the problems of it tries to have the best of both worlds, right? The appeal of the single table is that the performance is high performance. There's no need to join anything. Everything is in one single table. But the problem is that it's a very sparse table, right? So you'll have lots of records with empty data. So the appeal of the normalized strategy is that it's more intuitive, right? You split up multiple classes into multiple tables, and so it makes more sense, conceptually. The problem is that it has low performance. You have to join all these tables up and down. So the per table implementation, it tries to marry these two ideas. So instead of what it does is that it does create one table per class, just like what we would expect the normalized strategy to work, right? But it removes the need for joining, right? What it does is that it intuitively actually implements the inheritance the way we would expect. Notice that the true-false question only adds one field, but it copies over all the other fields from the base class, right, onto itself, right? So here, not only do you have the fields for the is true, but I also have the fields for my parent, right? So that I have the data right here for this object without needing to join myself with my parent class from my derived class. See that? So it truly copies all the fields down from the parent down to the child. So there's no need to do the join. So this is kind of like you get both the best of both worlds, right? The intuitive concept of having one table per class, but also the no need to join, right? So it's still performant.